So partial fraction decomposition. For the first 3 questions, all we do is set it up. We're not solving it. So our answer is going to have the A, B, and C in it. So what's the first thing we need to do to set this up? Factor the denominator. Here, I don't think this factors, so change it to negative 60. So it's x squared plus 7x minus 60. What are factors of negative 60 to add to 7? Five and 12. And which one's negative? The 5. So this is x minus 5 times x plus 12. I changed the question because I don't think negative 70 has 2 factors to add to 7. So the question was just wrong. So here we write our answer as A over x minus 5 plus B over x plus 12. And that's the answer. So all we're doing is setting it up. It does not matter the order. You could have A over x plus 12 and B over x minus 5. That's fine too. Number 2. What do I need to do first?
Take out GCF.
Factor the bottom, and I can take out a greatest common factor in the bottom. What's my greatest common factor?
3x.
3x. So I'm dividing both of these by 3x. So 3x goes on the outside. What stays on the inside? X squared minus 9. Can I factor this anymore? Yes. This is the difference of squares, so it factors into x plus 3, x minus 3. So how would I write my answer? I switched them, but it doesn't matter the order. If you had x minus 3 first, then x plus 3, that's fine too. So this is our answer. So all you have to do is factor it, and then you set each piece of the factor under its fraction. Ready for the next one? All right, so number 3. How can I factor the denominator? What's the greatest common factor? Negative 2x. So I'm dividing all of these by negative 2x. So negative 2x goes on the outside, and what am I left with on the inside? 3x squared plus 11x minus 4. Perfect. Now, how can I factor this? Multiply the first times the last. So what's 3 times negative 4? And what are 2 factors of negative 12 that add to 11? 12 and negative 1. Perfect. So in my parentheses here, I have x plus 12 times x minus 1. That negative 2x stays on the outside. What do I have to do next? Divide by 3. Since I started by multiplying, I have to make sure I go back in and divide. So this is negative 2x times x plus 4. What happens if it doesn't divide? Put it as a coefficient in front of that x. So I have 3x minus 1. So then I can write my partial fraction. So I have a over what? A over negative 2x plus b over x plus 4 plus c over 3x minus 1. So that's just setting it up. I'm going to do one more example also. Let's say I had 7x on top and then x plus 3 cubed on the bottom. So this is technically already factored for us. How would I write my partial fraction decomposition? A over what? X plus 3 plus B over?
X plus 3 squared.
Awesome. X plus 3 squared. And then plus C over?
X plus 3
X plus 3
cubed.
cubed. So remember, when you have an exponent on a binomial, you have to have all of the exponents leading up to it. So this is x plus 3 to the first power. Then we have x plus 3 squared and x plus 3 cubed. All right, next we're going to be solving. So find the partial decomposition of the following. So we actually have to solve these. So the first thing we do is set it up the same way we did the last ones, but we just have to solve. So what do I do first to factor the denominator here?
First and last.
Multiply the first times the last. So this would be 42. And what are two factors of 42 that add to 13? 7 and 6. Awesome. So I have x plus 7, x plus 6. Divide both of them by negative 3. Since I started out by multiplying 3, I have to make sure I go back in and divide. So if it doesn't go in, what do I do with the negative 3? Put it in front of the x. So this is negative 3x plus 7. And then 6 divided by negative 3 would be negative 2. So x minus 2. So I set up my partial fractions again. I have a over negative 3x plus 7 plus b over x minus 2. What do I do next to solve? Awesome. So I multiply my numerators by whatever's missing in that denominator. So here I only have negative 3x plus 7. I'm missing an x minus 2 in the denominator. So I'm going to multiply a times x minus 2. And then in my b fraction, I'm missing negative 3x plus 7. So I'm going to multiply b times that. Then what should I do? Perfect. I set the numerators equal to each other. So negative x plus 7 is equal to a times x minus 2 plus b times negative 3x plus 7. Now we can plug in whatever we want for x to solve for a and b, but it's going to be easiest to plug in whatever makes this 0 and whatever makes this 0. Yes. It's the numerator here. So we set the numerator on the left side equal to the numerators on the right side. So what would make x minus 2 equal to 0? What value of x? So x is going to be equal to 2. That's going to be one number we plug in. What would make negative 3x plus 7 equal to 0? 7 over 3. So that's going to be another value we plug in for x. So I'm plugging in 2 first into all of my x's. So negative 2 plus 7 is equal to a times 2 minus 2 plus b times negative 3 times 2 plus 7. Now what happens to negative 2 minus 2? I mean 2 minus 2. It cancels out. This becomes 0, so a cancels. So you're only going to be solving for one variable at a time. So here we're solving for b. If you know that a cancels here, when I plug in 2, I know a is going to cancel. I don't even need to write that down in my equation here when I'm solving. I could just write the left side and b, because I know a is going to cancel. So then I solve from here. I have negative 2 plus 7 is equal to b times negative 6 plus 7. What's negative 6 plus 7? 1. And negative 2 plus 7 is 5. So 5 is equal to b. So next, I'm going to plug in 7 over 3. So I have 7 over 3 plus 7, negative 7 over 3 plus 7 is equal to a times 7 over 3 minus 2 plus b times negative 3 times 7 over 3 plus 7. So let's work it out. So if I add a fraction and a whole number, I need a common denominator. So I'm going to make this 21 over 3. So this turns into 14 over 3. Same thing here. I need a common denominator to subtract these. So 7 over 3 minus 6 over 3. So it's 7 over 3 minus 6 over 3. 1 over 3. So 1 over 3a. And then here, the 3's cancel. So I have negative 7 plus 7, which is 0. So b goes away because b is 0. B times 0 is 0. So since it's b times 0, we can just cancel it out. Get rid of it. So now I'm solving 14 over 3 is equal to 1/3 times a. How do I solve for a? Divide 1/3 or multiply by 3. So I multiply both sides by 3. It'll cancel out here and cancel out there. So I have 14 is equal to a. So then I just plug them into my partial fraction up at the top. Make sure you plug in a into a and b into b. That's probably the easiest step in all of this, but people still get them mixed up. So we have 14 over negative 3x plus 7 plus 5 over x minus 2.
That's the complete answer. It's not like equal to anything.
That's our complete answer. It's equal to this.
So we're gonna write that.
You don't need to write it. Okay, so what's the first step? Take out the greatest common factor. So that would be x. What am I left with when I take out an x? X squared minus 100. Can I factor x squared minus 100? X plus 10, x minus 10. Since it's the difference of two perfect squares, it factors into x plus 10, x minus 10. So when I set up my partial fraction here, I have a over x plus b over x plus 10 plus c over x minus 10. What's next? I have to multiply by what's missing. So here I only have x, so I'm missing x plus 10, x minus 10. So I'm going to multiply this times x plus 10, x minus 10. What do I need to multiply to b? X and x minus 10. And what do I multiply times c? X and x plus 10. So you multiply by whatever is missing in the denominator. What's next? Set the numerators equal to each other to set up our equation. So 17x minus 12, that's what's on the left side of our equation, is equal to a times x plus 10 times x minus 10 plus b times x minus 10 plus c times x minus x plus 10. So now I need to figure out what makes each piece here 0. So what makes x plus 10 0? So x is equal to negative 10 is going to be one number that I plug in. What makes x equal to 0? 0. So x is equal to 0 is going to be another number that I plug in. And then what makes x minus 10 equal to 0? Negative 10. Nope. Positive 10. We already have negative 10. Here, negative 10 makes it 0. This one, positive 10, makes it 0. And then this one, 0, makes it 0. When we're done. Yes. All right, so first we want to plug in negative 10. So I have 17 times negative 10 minus 12 is equal to, what happens when I plug in negative 10 into this x plus 10? It becomes 0. So then no matter what this is, it'll be negative 20. What's negative 20 times 0? 0. And a times 0 is 0. So the a goes away. So I don't even need to write that down because I know it's going to go away. So I'm just going to save myself the work. Next, I can plug in negative 10 into b, into the x's in the b part. So I have negative 10 times negative 10 minus 10 times b. What happens when I plug in negative 10 into here in this x plus 10? It becomes 0, so c cancels out. So I'm only solving for b here. So just do the work. We have negative 170 minus 12 is equal to, this becomes negative 20 times negative 10, which is 200 times b. So negative 182 is equal to 200b. What do I do next to solve? Divide by 200 and simplify our fraction. So what goes into both negative 182 and 200? 2. We know 2 does for sure, so let's start with 2. So negative 182 divided by 2 is negative 91 over 100. Can we simplify this anymore? No. So that's one answer. That's our B. So next I'm going to plug in 0. So I plug in 0 into all of my x's. So I have 17 times 0 minus 12 is equal to a times 0 plus 10 times 0 minus 10. What happens when I plug in 0 here? B cancels out. And what happens when I plug in 0 here? C cancels out. So I'm just going to save myself the time and not even write them down because I know they're just going to go away. So let's solve. 17 times 0 is 0 minus 12 would just be negative 12. Then this is a times 10 times negative 10. Negative 100. Divide both sides by negative 100. So a is equal to what?
3 over 25.
I can divide both of these by 4.
Yeah.
So 3 over 25. Perfect. So that's A. C. Yes. All right. So last, I'm going to plug in 10. So I plug in 10. This is 17 times 10 minus 12 is equal to, what happens when I plug in 10 here?
Cancel.
It becomes 0, so A cancels out. What happens when I plug in 10 here? It cancels, so B goes away, and then C, I can plug it in. So I have C times 10 plus 10. So let's solve. 17 times 10 is 170 minus 12, 158. This becomes 20 times 10, which is 200. Divide both sides by 200. Can I simplify 158 over 200? So 2 goes into both of them. So it becomes 79 over 100. So once we found A, B, and C, what's the last step?
Put them back in their base thing.
Plug them in. So A is 3 over 25. So the numerator stays on top, the denominator goes on the bottom. So this is 3 over 25x, because it's just x on the bottom. So I'm plugging it in here, which we don't need the parentheses. I'm just showing you that we can write them, because it's 25 times x. Next, we have B. B is negative, so it becomes minus. The numerator stays on top, the denominator goes on the bottom. So negative 91 over 100 times x plus 10. You don't have to distribute it to the denominator, but you can if you want. And then C is positive, so it goes back to plus. The numerator stays on top, the denominator goes on the bottom. So 79 over 100 times x minus 10. So this is our answer.